Right now, there are over 8 billion humans on this planet. We're everywhere, every continent, every climate, cities, deserts, mountains, ice caps, you name it, we've built a home there. We've sent people to the moon. We've mapped our own DNA. We've built machines that can talk back to us. But here's something most people never learn in school. There was a moment in our history when almost none of that ever happened. A moment when humans almost didn't make it at all. Not almost as in things were tough. Almost as in scientists believe our entire species may have dropped to just a few thousand people, maybe fewer than the population of a small town today. One bad chapter and none of this, none of you, none of me, none of human history, would exist. So what nearly wiped us out? Let's go back roughly 70,000 years and find out. Picture Earth 70,000 years ago. No cities, no writing, no farming, just small bands of Homo sapiens, us, scattered mostly across Africa, surviving as hunter-gatherers. We weren't the only humans around either. Neanderthals were living across Europe. Other human relatives were scattered across Asia. Multiple human species, all trying to survive on the same planet at the same time. And life was already hard. No hospitals, no stored food supplies, no warning systems for disaster. If the climate turned against you, you had nowhere to go and no one coming to help. Every single day was a negotiation with survival. Then something happened that pushed early humans right to the edge. On the island of Sumatra, in what's now Indonesia, a volcano called Toba erupted. But calling it a volcano eruption undersells it completely. This wasn't like a normal eruption you've seen in documentaries. Scientists classify it as a supervolcanic eruption, one of the largest in the last 2 million years of Earth's history. The explosion was so massive it's estimated to have ejected somewhere around 2,800 cubic kilometers of material into the sky. To put that in perspective, that's enough material to bury an entire country under a thick layer of ash. Ash reportedly fell as far away as what is now India and Pakistan, thousands of kilometers from the eruption site. Entire regions were blanketed in gray dust, rivers were choked, plants were smothered under a layer of debris that some estimates suggest was centimeters thick, even far from the volcano itself. And it didn't stop at ash. Massive volcanic eruptions like this throw huge amounts of sulfur into the upper atmosphere. That sulfur forms tiny particles that reflect sunlight back into space, which means less heat reaches the ground below. Some researchers believe this triggered what's called a volcanic winter, years, maybe even up to a decade, of cooler global temperatures, disrupted rainfall patterns, and collapsing plant life across huge parts of the planet. Now imagine you're a hunter-gatherer relying on plants and animals for food, and suddenly the plants are dying and the animals that eat those plants are starving too. There's no supermarket to fall back on, no stockpile buried for emergencies, just whatever the land gives you, and the land had stopped giving. Here's where it gets really interesting, and honestly a little chilling. Scientists didn't figure this out just from volcanic ash sitting in the geological record. They found a second clue buried inside our own DNA. When researchers study human genetic diversity, basically how different we are from each other genetically, they notice something strange. Compared to many other species on Earth, humans have surprisingly low genetic diversity for how many of us there are today. That's unusual. If you compare us to, say, wild chimpanzee populations, you'll find that even small groups of chimps living just a few valleys apart in Africa can be more genetically different from each other than humans are across entire continents. One leading explanation for this is what's called a population bottleneck, a period where the number of breeding humans dropped so low that the entire species had to essentially rebuild itself from a small surviving group, generation by generation. Some estimates put that number at just a few thousand individuals, a few thousand, not a few thousand in one town, a few thousand total, representing the entire future of the human race, packed into scattered pockets of survivors who likely never even knew about each other. Every single person alive today may be descended from that small surviving population. Every language, every culture, every civilization that's ever existed, traced back to a genetic bottleneck so narrow it's almost hard to believe we made it through. Let's make that number feel real for a second. A few thousand people. That's smaller than most high schools, smaller than the crowd at a local football match. If you've ever stood in a mid-sized concert venue packed shoulder to shoulder, that's roughly the size of the group that may have carried the entire future of humanity forward. For comparison, conservationists today consider a species critically endangered once its population drops into that same range. Mountain gorillas, for example, were down to just a few hundred individuals at their lowest point in the 20th century, and that number alone put them on the edge of extinction in the eyes of scientists. Early humans, by some estimates, weren't far off that same danger zone. Here's another fact worth sitting with. Geneticists estimate it can take a species tens of thousands of years to rebuild genetic diversity after a bottleneck that severe. That's part of why humans today, despite our huge population, are actually more genetically similar to one another than chimpanzees are to other chimpanzees living just a few valleys apart in Africa. We recovered, but the fingerprints of that near collapse are still written into our genes today, in every single one of us. So what did it actually take to survive something like this? Researchers who study early human sites from around this time period have found some fascinating clues scattered across the African coastline. Some coastal groups in southern Africa appear to have leaned heavily on marine resources, shellfish, coastal plants, food sources that wouldn't have been as vulnerable to the disrupted climate further inland. Caves along the southern coast of Africa have revealed layers of shellfish remains and tools dating back to around this period, suggesting these groups had found a lifeline the volcanic winter couldn't fully take away. Being near a resource that didn't fully collapse may have made all the difference between a group that survived and a group that simply vanished. Cooperation likely mattered too. Small bands sharing knowledge, sharing food, sharing shelter. In a crisis like this, isolation was close to a death sentence. Groups that stuck together, pooled resources, and adapted their behavior fast had a better shot at making it through. Groups that didn't simply disappeared from the historical and genetic record, leaving no trace behind. It's a sobering thought that the reason you exist today might come down to a small group of ancestors who happened to be in the right place, doing the right things, at exactly the right time in history. Remember, Homo sapiens weren't the only humans on Earth back then. Neanderthals eventually went extinct, disappearing from the fossil record roughly 40,000 years ago. Other early human relatives across Asia, like the Denisovans, disappeared too, leaving behind little more than a few bone fragments and traces in our DNA. We were the ones who made it through. Not because we were guaranteed to, but because of some combination of luck, adaptability, and geography. Now, it's worth being honest here. Not every scientist agrees on exactly how severe the Toba event was for humans, or whether it was the sole cause of the bottleneck. Some researchers have found archaeological sites in Africa and India showing continued human activity right through the period of the eruption, suggesting some groups may have weathered it better than once thought, and that the disaster wasn't universally devastating everywhere at once. The genetic bottleneck evidence itself is still debated too. Some scientists think it may have been caused by multiple smaller climate pressures stretched out over a longer period of time, rather than one single catastrophic volcanic event. Ice ages, shifting rainfall patterns, and repeated droughts across Africa may have all played a role alongside, or even instead of, Toba. But even with the scientific debate still ongoing, the core fact remains largely unchallenged. Something, whether it was Toba alone or a combination of climate pressures around that era, pushed early human populations dangerously low. We really did come close to disappearing entirely. So next time you look at a city skyline, or a crowded street, or literally any group of more than a few thousand people, remember? There was a point in history when that many humans might have represented our entire species, worldwide. Every person who has ever lived, every book ever written, every language, invention, and idea humanity has ever produced. All of it traces back to a group of survivors small enough to fit inside a single stadium. We didn't just build civilization from nothing. We very nearly didn't get the chance to build anything at all. If you found this as unsettling as I did, subscribe. because next time we're diving into another moment in human history that almost didn't happen.